We hear many different kinds of sounds all day. People talking to each other in the house, the noise from the street outside, the rattling of vehicles, the clanging of pots and pans, the bell ringing every period in school, the rustling of leaves, melodious instrumental music on the radio. We get to hear such a variety of sounds. Each of these sounds is different. Every animal, too, has a different sound. The roaring of a tiger, the howling of a jackal, the baying of a wolf, the neighing of a horse, the barking of the dog, the call of the cuckoo, the twittering of sparrows, the cry of the peacock. We have a number of words for these different sounds. How is sound produced? What happens when we make a sound by clapping our hands? Let us try. As you speak, place a finger lightly on your throat. You will easily feel the movement in your throat. Place your hand over the speaker of a transistor radio. Your hand will feel some movement. Thus, you see that movement, that is vibrations. Hence, we can say that vibration is necessary for sound to be produced. Let us try an experiment to verify that vibrations are necessary for production of sound. Stretch a rubber band with your thumb and first finger and hold it close to your ear. With a finger of the other hand, pluck the stretched rubber strings. The strings vibrate and you hear a certain sound. Vibration of the source is necessary for sound to be produced. When the strings of a sitar are plucked, we hear musical notes. When the stretched membrane of the labia is struck, it vibrates and we hear its characteristic sound. How is sound produced in a flute? When we blow into one end of a flute, a column of air of a specific length vibrates and sound is produced. Let us try to understand what vibration is. Tie a weight to one end of a fine string and hang it from a support. This is a pendulum. Allow the string to come to rest vertically in the position PA. Now, pull the end A aside to point C and let go of it. The pendulum swings from C through A to B and back through A to C. This motion is one swing. This is called oscillation of the pendulum. When an object moves very fast, following a fixed path from one side to the other and then back again, we say that it vibrates. The time taken by a pendulum to complete one swing or oscillation is called the period of oscillation of the pendulum. It is denoted by capital T. In this example, time taken to move from B to A to C and again from C through A to B is the period of oscillation T of the pendulum. The period of oscillation is measured in seconds. The number of oscillations that an object completes in 1 second is called the frequency of vibration of the object. It is denoted by small n. Thus, we express frequency n is equal to 1 upon period of oscillation t. The unit of frequency is per second. Let us try to find the relation between the period of oscillation and the length of the pendulum. Measure the length of the string used in the previous experiment in meters. Pull the pendulum aside and allow it to swing. Use a stopwatch to measure the time taken for 20 oscillations. Now, reduce the length of the pendulum by 10 centimeters. Again, measure the time taken for 20 oscillations. Repeat this 4 or 5 times and write your observations in the following format: length of the pendulum, time for 20 oscillations, period of oscillation T. And using the formula for frequency is equal to 1 upon T, calculate frequency. After performing an experiment, it can be inferred that the period of oscillation, T, depends upon the length of the pendulum. If the length of the pendulum is increased, the period also increases. Let us now understand what is meant by amplitude of oscillation. The maximum distance that the pendulum moves away from its position at rest is called the amplitude of oscillation. In the experiment in which we calculated frequency of oscillation, AB is the amplitude of oscillation. A vibrating object vibrates within the limits of the amplitude of oscillation. Let us continue the same experiment. Keep the length of the pendulum constant and find the frequency and period of oscillation using different amplitudes. Whatever the amplitude, the frequency remains the same. As amplitude is a distance, it is measured in meters or centimeters. There are some sounds we can hear and some we cannot hear. This means some sounds are audible and some are inaudible. Why can't we hear some sounds? Let's see. You have learnt that vibration of the source is necessary for sound to be produced. Do vibrations of all kinds produce sound? You might swing your arms back and forth and it would be a kind of vibration. However, at the most, you can swing your arm 4 or 5 times in 1 second. In other words, the frequency of the movement of your arm is, say, 4 per second. The unit called Hertz or Hz is used to mean 1 cycle per second. We cannot hear the sound produced by a frequency of 4 Hertz. That is, it is inaudible. The human ear cannot hear a sound of frequency less than 20 Hertz. It is said to be an infrasonic sound. Similarly, sounds of frequencies higher than 20,000 Hertz are also inaudible. Such sounds are called ultrasonic sound. It means that we can hear sounds of frequencies between 20 Hertz and 20,000 Hertz. Therefore, these sounds are called audible sounds, that is, sounds that we can hear. Dogs, bats, etc. can hear ultrasonic sounds. Bats actually produce ultrasonic sounds while flying in the dark. That sound is reflected from objects in front of the bat. From the reflected sound, the bat comes to know the position of things in its surroundings. In fact, it can be said, with the help of ultrasonic sound, a bat sees with its ears rather than with its eyes. The radar system too tells the position of objects by getting the waves it produces reflected from the targets in front. Ultrasonic sounds have proved to be a boon in medical and other sciences. A kind of radar system called sonar has been derived from it. Ultrasonic sounds are produced and caused to be reflected from the inside of a metal. This helps to detect faults or impurities inside the metal. Similarly, the system of ultrasound scanning is used to find out the condition of the fetus inside the womb. This is also called sonography. Ultrasonic sounds are also used for measuring the depth of the ocean floor.